56 reduction in dollars per kilowatt hour at the battery pack level, and a 69 reduction in investment per gigawatt hour, which is the true enabler. So what this enables us to do is achieve a new trajectory in the reduction of cell cost, and now to be clear, it will take us probably a year to 18 months to start realizing these advantages, and probably to fully realize the advantages probably. It's about 3 years or thereabouts. Elon Musk once set an ambitious goal for Tesla's 4680 battery by 2023, which is to dramatically reduce the cost of battery production compared to before. So the question is, let's find out in today's episode of Tesla Car World. Welcome back to our channel. If you're new, we'd appreciate it very much if you would show your support by subscribing to our channel and ringing the bell so you won't miss out on exciting new episodes. Now, let's get started on today's content. As per a new report by Cairn Energy Research Advisors, Tesla holds a sizable lead over competitors when it comes to paying less for lithium battery cells and having the lowest cost electric vehicle battery packs. In 2021, Tesla paid an average of $142 per kilowatt hour. By comparison, GM paid an average of $169 per kilowatt hour for its battery sales, while the industry average runs at about $186 per kilowatt hour. The Tesla CEO said Tesla will bring down the cost of the 4680 batteries in the future thanks to several components such as cell design, cell factory, anode materials, and cathode materials. The new 4680 tablet cell has 5 times more energy, enables 16 more range, and harnesses 6 times more power. It also lowers the dollar per kilowatt hour cost of the battery by 14. It can be estimated that after 4680 batteries are put into production in the future, Tesla may be able to reduce its cost to about $50 to $55 per kilowatt hour. According to some sources, currently Tesla has not used silicon in the anode material of the 4680 cells yet. Instead, the anode active material is graphite. However, Tesla revealed that the new method for using silicon in the anode will also lead to a decrease in the cost of producing 4680 cells. Aside from that, silicon is widely considered the next big advance, because the theoretical charge capacity can be about 10 times that of a typical graphite anode. Because it's the most abundant element in the Earth's crust after oxygen, which means it's everywhere it's sand, then they will introduce a step change in capability and cost up to $1.20 per kilowatt hour, which is about 6 to 10 times cheaper than existing methods that have been used to date. Meanwhile, the cathode of the 4680 battery cell is equipped with an NCM or nickel cobalt manganese 811 chemistry. The NCM 811 is a low cobalt content, which means nickel to cobalt to manganese at a ratio of 8:1:1. The material characterization indicates nickel content accounts for 81.6%. Additionally, Tesla could consider using alternative materials in the 4680 battery to optimize its production cost, because cobalt is the most expensive metal in the components for the production of the 4680 batteries. For the past 4 years, the average cost of cobalt was higher than the cost of all other battery metals put together. Chibiz Amanchukwu, professor of molecular engineering at the University of Chicago, said for mass electrification to happen, there are lots of sentiments that cobalt needs to be eliminated or reduced to the bare minimum. Some cobalt-free batteries do already exist, but they require some trade-offs. An analyst said there is already a viable cobalt-free battery, and that is lithium iron phosphate, but the main downside of the LFP battery is low energy density and therefore driving range. Lithium iron phosphate batteries have improved, leading more car manufacturers to adopt the technology, which is far cheaper than batteries with cobalt. Tesla already uses lithium iron phosphate batteries in the Model 3 and Y vehicles it manufactures in China, and Tesla says it will now expand the use of lithium iron phosphate batteries to all its entry-level Model 3 and Model Y vehicles. Although Elon Musk has a big goal of reducing the production cost of the 4680 battery in order to decrease the production cost of Tesla electric cars. Tesla still faces difficulties and challenges before optimizing the 4680 battery completely. Accordingly, Tesla still hasn't used silicon for the cathode of the 4680 battery, even though it saves on costs. Andrew Blaglino, Tesla's senior vice president powertrain and energy engineering, explains as follows: the main reason is because the challenge with silicon is that it expands 4x when fully charged with lithium, and basically all of that expansion stress on the particles start cracking. They start electrically isolating. You lose capacity, the energy retention of the battery starts to fade, and it also gums up with a passivation layer that has to keep performing as the particles expand. Not only that, Tesla faces a lengthy process in ramping up a battery factory, complicated by plans to use a new manufacturing technology called dry electrode coating. Casper Rawls, chief data officer at Benchmark, said there is a very long process of fine-tuning the equipment before you can get to volume production. Battery production is hard, even harder for experienced suppliers. Tesla would have to refine the manufacturing process this year to ensure volume production in 2023. The crowning difficulty for Tesla is that it is planning a new manufacturing process called a dry electrode, a technology it obtained via its 2019 acquisition of California startup Maxwell Technologies. Musk said the factory equipment doesn't exist, it's being made. Dry electrode manufacturing skips a traditional complicated step of battery manufacturing that involves a chemical slurry. If it works, it'll be cheaper and more efficient, but Musk freely admits it will be a challenge. Even so, analysts are optimistic that Tesla will overcome this issue. On top of that, Tesla's CEO encouraged entrepreneurs to enter the lithium mining business today. This request came during Tesla's second quarter of 2022 earnings call that took place recently. Well, we don't want to go into the mining industry or the sort of refining industry for because the limitation, I think, is actually more. For example, with lithium, it's more lithium refinement than it is the actual mining. So you better take the order that contains lithium and you've got to refine it and get it to battery grade lithium hydroxide or lithium carbonate. And it has to be extremely pure, otherwise, you could have a breakdown in the cell. In addition to that, in a recent podcast, Elon Musk said, to summarize, although the new battery technology of the 4680 cells still needs more time to develop and perfect, Tesla retains its technological leadership in the industry, continuing to challenge its rivals such as GM, Volkswagen, and so on. And with that, today's episode has come to its end. We sincerely thank you for watching and for all of your support of our channel. As always, if you enjoyed our video, please leave a like, share the video, subscribe to the channel, and ring that bell to stay up to date on exciting developments in the world of EVs. And be sure to leave a comment down below to tell us what you thought about today's content. Once again, we thank you so much. From all of us here, we hope to see you again next time. Until then, take care and be safe.